we explored the first few airfoils in detail. Let's go back and have a look at even more detail to the first airfoil. So at this point you might want to save your file as airfoils 2. Okay, and then take this for loop away, choose the first one, and then take that away, the plot and the time. So take this away. Okay, this will just draw the first one. Let's have a look. Okay, so this is our first airfoil. Now on the graph here, I show you the foil X and Y points. In the next 5 to 10 minutes, I want to show you how I can indicate the centers of each of these panels. Now, the panel is the region between 2 points. So, in order to begin that, let's have a look at foil X and foil Y coordinates. So, how many panels are there on the graph? Well, the number of panels is of course 1 minus the length of foil X. So I have 35 points here. Therefore, I have between the first panel is between the 0 and 1. The next panel is between 1 and 2, etc. So we have 34 panel centers, up to 34 panels. So these are the panels that I am talking about. So how can the question is, I want to find the centers of these panels. How can I do that? In order to do the panel centers, so let's do X center is the panel centers, or if you want to make it panel X center will be foil X so the centers are the 0th X plus the first X over 2. So in other words, the first panel X will be something like this. So the X coordinate of the first point plus the X coordinate of the next point over 2. Over 2. In this way, I can generalize this and write this in a vector form that we have done quite a number of times before. You will recognize this representation. So this one is all the X coordinates but the first one. And this is all the coordinates but the last one. So the last one not included, first one not included. And if I divide this by over 2, will give me the panel centers for each of these points. And you can see that the length of panel XC will be 1 minus the number of points. So let me run this part and then have a look at panel X coordinates, panel X coordinates of the centers. Okay, let's have a look at its length. 1 minus the number of x coordinates. Likewise, I will do this for the y centers. So the y center of a panel is the y coordinate of the forward point minus the y coordinate of the point before that over 2. So let's run this. Okay, let's see if we are actually finding the panel coordinates by now plotting at panel x center, panel y center, and let us do this with small dots so we can identify them. It automatically gives a different color, and yes, so this is the panel center over there, second one, and so on. So I have identified all the panel centers. What can I do with that? Well, I can do quite a lot actually when I have the panel X and panel Y centers. How about I put a vector on the panel coordinates? Just any vector. Remember, we do curve plots at panel XC and panel YC. So this is like an irregular coordinate set for the X and Y. And let's apply the same vector on each of these points, and then I can do a scale. I think this is going to be large, but I can change that in a moment. Okay, so on each of these points I have a vector. As I suspected, the vector is large, so let's make it smaller by making the scale larger. Okay, and that might be too small. Even that is too small for me. Okay, now I am putting on the panel centers the same vector I want. So I can change the vector. I am doing this just to show you that I can put vectors on the panel centers. I can also do this for the panel x and y coordinates directly, which I don't want to at this point. Okay. Now, instead of this same vectors, how about I ask you the question? Let me bring back. Okay. Now, is it possible? Can you think of a way to plot the panel normals, the perpendiculars vectors to the panels? Can I do that? How can I draw the perpendiculars unit vectors that is perpendicular to each of these panels? I want you to make sure that you understand each of these panels is a linear line from this point to the next. So this is a line, so therefore it has a slope. Using that slope, how can you get the panel normals? Maybe you want to pause the video at this point and think for yourself a little bit before moving forward. I want to do the panel. I want to calculate the panel normals from the panel tangents, and this is how I go about doing that. So the slope of a panel is a vector that is so this is the tangent vector of a panel. So panel tangent x is this time if I do foil 1 minus foil, so the same expression here but with a minus, so I am subtracting this one from that one, so this is going to give me a delta x, and then I don't really divide it by 2 here, don't have to, it won't make a difference, and then the y likewise foil x, this is for x and that is for y. Okay, panel tangents x and tangent y. So as you see, this is also equal to the number of panel centers. We run this and then do the length of foil x. This is 35 panel centers, 34, and panel tangents also 34. So I want to use this as my vectors components now. Panel tangent x and tangent y. Delta x and delta y will be the components of my vectors now. So let's do the curve plot again. Where do I want to do that? At panel centers. Panel centers. And then I want to, my coordinates are panel tx and panel ty. And the scale, I think we can begin with this one. And then find the right one next. So panel coordinates, vector components, and the other parameters that I. So let's run. I think my vectors are too small to be represented here, so make them. Okay. As you can see, now my vectors follow the slope of the panels. I can make them a little bit transparent to make them look better. Okay, at this point maybe I can take off the panel points, okay, and show only the panel centers, or I can take the panel centers off as well. Okay, so these are the slopes of my airfoil panels. But my original question was not the tangents, but the normals. So I am looking for the normal, I am looking for a vector that is normal, that is perpendicular to each of these vectors. And I know the components of my vectors are this one. So how do I get the vector that is perpendicular to this vector? So that is panel normal x and panel normal y components. Well, if you think about it, the dot product of two vectors is the sum of their components multiplied. And because the dot product of two perpendicular vectors is 0, if I do panel normal x equals minus panel y ty, and then this one should be positive. So have a look at this. before we move forward. So if you multiply panel NX and panel TX and NY and TY, we get 0 in this case. So their dot product is 0, meaning that these are perpendicular. And the next step, I want to make this a unit vector also. How do I do that? Panel, I can get the length of my panels and then divide. So I have done this with a function before. So I can open that function if I want to, or I can define it again here. So instead of bringing the function in, this is rather straightforward. So I want to do it directly here. NumPy sqrt panel normal x plus panel normal. Okay, maybe a better idea is to do this for the tangents. Panel tangent x plus panel tangent y squared, and the square root of this. If I do this for the tangents, panel tangent x over L, so I am scaling it with its length to get the unit vector. If I do the same for ty, at this point my tangents are all unit, so I am doing the unit vector for the tangents. Therefore the panel normals will be unit vectors as well. So before doing the normals, let's have a look at the panel tangents at this point. Okay, so these, because they are now larger vectors, I can make the scale. So as you see, I have a nice unit vector pointing the tangents. And then the normals are like this. So as you see, we can, so the normals, okay, it's actually giving me the negative one, so I can do a, it's not going to change. So now I can see my normals nicely pointing away from the airfoil. Let's bring this panel normals here, so I can see where the vectors are located. So this is the panel normals. Those dots are the panel normals, and these are the panel normals at the centers of each panel. Okay, we have covered quite a bit again. Now I know in which direction the panels are. I know in which direction the panels are directed, because I know their normals. In the next video, I want to superimpose a normal flow and find the components of the normal flow along these vectors. Okay, see you in the next video.